DataCon LA. I'm sorry this is virtual, but I wanted to give my presentation anyway, and thank you for attending. My name's Dave Stokes. I'm a community manager for MySQL products, which means until this year I used to travel around a lot evangelizing on MySQL. This year has been quite the show, as you're aware. By the way, if you need to get a hold of me, here's my contact information, and the slides are up, slideshare.net/Dave Stokes, and the organizers of this show will have them available too. Hopefully we'll have the Q&A after this if I can speak fast enough, and we'll get everything going. So today we're talking about MySQL without using SQL. By the way, I have to have the Oracle Safe Harbor Agreement since I do work for Oracle. During the Q&A, I get off on tangents on new projects that are coming. Take any information I give you in that regards with a grain of salt. I do not have perfect information of what's coming, and I don't mean to mislead you. It's just that I don't know what the final product's going to look like. Okay, we're mainly talking today about the MySQL Community Edition. There's an Enterprise Edition. Community Edition is free to download and use under the GPL version 2 license. Go to mysql.com and look for the downloads. There's an Enterprise Edition that comes with a subscription. That comes with some enhanced tooling and that all-important support number, so when things go bad in the middle of the night and you want someone to call, we're there. So today we're talking about NoSQL and SQL together using the MySQL document store. Traditionally, relational databases have been a great thing for the past many decades. The original goal was to save data with minimal duplication because disks were slow and expensive. SQL has basically been around for 45 years, and it was the first language to have the concept of getting many records back from a single command. Before that, it was ask for one, get the next one, etc. So the great thing about relational databases, part of the idea with not duplicating data, was the normalization of data, putting things down to small logical compartments with constraints. So you could have a customer order number that would go down to, the customer ID came in their customer table, order number with that customer ID on there, and then from there you look for shipping information, all those tables tied together. Also you had atomic consistency, isolation, durability for the ACID compliance, which give you transactions where everything either went in as one group of data or not. And by the way, SQL has become a very powerful query language in the past 45 years, and it still grows. The standard committee is still adding new features. The big trouble was that you needed to set up a lot of tables before you could use it. That also included indexes, normalizing the data, doing a bunch of query optimizations before you had a chance to put anything in there. Once you had that structure set up, it was very hard to change, which meant you needed a DBA or someone with DBA skills to do that sort of work, and that can often become a choke point. So NoSQL databases were rediscovered about 10 years ago. They were there before SQL. Things like the Berkeley database, which is still a product, and you can get it from Oracle. And anyway, the big change about 10 years ago was that people started saving stuff in JSON format. The good idea is there is it's schemaless. You don't have to normalize your data. You don't have to set up foreign keys. You just start dropping in JSON documents. Very flexible. It's great for things like IoT devices that spit out JSON, and JSON has become the interchange format of choice. The other thing is you end up with object persistence without having to use an object relational mapper. That extra layer has wounded a lot of projects in the past. So the idea of a JSON document store is highly sought because JSON is interchange format of choice. It's close to the front end. No matter what language you program in, nowadays you're doing a lot of stuff in JavaScript also. And it is fairly easy to learn, much easier than something said like XML. So DBAs see the world in a series of structured tables and how they relate. Developers, they see things more like what you see on the right. This is a JSON document from the World X database that MySQL uses for examples, education, and documentation. As you can see, not quite a good match there. But what if you had a way where you could have both SQL and NoSQL on one stable platform on a well-known technology with a large community in a very amazing ecosystem? Well, that's the MySQL document store. It's a solution for developers because it gives you all the schema stuff you want for quick action. Operations folks love it because they know MySQL. We've been around for 25 years. Replication, backup, restoration is well known. And for business owners, they love it because it has the features like transactions, and it's very extensible. So what you're going to get is a flexible JSON document store. You don't need to use SQL. The good news is that it's built on top of a new developer API, which we call the X DevAPI. And by the way, you can use it with both standard relational tables and JSON documents, no problem. Limits documents are 1 gigabyte. Compare that to Mongo's 16 megs. It's a column, so if you need 2 gigabytes, you can have 2 columns. The API follows a lot of modern programming styles, and you'll see that it's very easy to pick up. I've seen junior developers who were fighting trying to learn SQL because it is a descriptive language instead of a procedural or a demand language. They were able to pick this up very quickly. It's easy to read and very extensible, and as I mentioned earlier, it also works with relational tables. We have connectors for all the popular languages, and if you have a language that's not on here, let me know. And I can get to the managers. We also have a new shell that has a lot of interesting features. It also has 3 modes: SQL, as you expect, Python, and JavaScript. So if you have libraries with those languages, you can use that to work with your data. Also, our new API is designed to work around non-blocking asynchronous calls, following the programming language designs. So if you have an application that fires up 5 or 6 queries to different tables, as it starts up, they can go off that and get those returned asynchronously. And it's all based around CRUD operations. Everything for X DevAPI is built on top of Google protobufs. It's not an ORM. So as you see here, this is actually a query where we're going through to a document collection named collection name in the schema test. We're going to do a search on the key of ID where it's equal to some value. This is sort of our model where we have the SQL API you're all used to, and the new X protocol, which does the CRUD API and the traditional SQL API. This is the way we'd like to have you see your application model. Here's your application using a MySQL connector. Talks to MySQL router, which is a lightweight level 4 proxy, which can sit on the same platform as your application. If you need a level 7 router, we recommend Proxy SQL. It's not a MySQL product, but it's a very nice product. And in this case, we have a 3-node read-write split. One machine is handling all the writes, and any machine can answer a read. Router knows which machine is least busy and will route the traffic that way. Something goes wrong in our NODB cluster here, and one of the other machines will be promoted to the write primary. Now you could also run this as a multi-master primary where all the machines act as masters. And all this is administered with our new MySQL shell. This is an example of the code in PHP. Once we authenticate in, which is you're going to do with any programming language or any API, login is in this case user root, password on the machine. New protocol listens to port 33060 versus 3306, the traditional MySQL port. Once we're in, we want to talk to the schema, in this case role X. In that schema, we want a document collection named country info. And from that collection, we're going to find all the records where a field named _ID is equal to USA. We determine the fields we want to grab and execute. No SQL. Here's an example in JavaScript. Once again, authenticate in. This time we're going to get the schema test. We're going to create a collection called My Collection, add 1, 2, 3 records, and then we can go out and find. Notice we can bind parameters. In this case, we're going to go out and find records where the name is like param1 and age is under param2. And here we're going to bind values $wildcard and 20 to the 2 parameters. Once again, no SQL. Don't like JavaScript? Here's roughly the same code in Python. So we get the schema, grab the document collection, do our adds, and go out and do our query. Don't like those languages? We support Node. We also support C++. I don't have a .NET example in here, but we support a lot of things. And of course, Java. Now, the new shell is a very interesting tool. Once you fire it up, you'll notice that it's no longer monochromatic. And in this case, JS means it's talking JavaScript. We also have a Python mode and SQL mode. So here I've connected in as root on localhost. I've created a session. For the session, I'm creating a schema called scale. And then I say I'm going to use that schema. And once I'm in that schema, DB points to the current schema. I say create collection. I'm creating a collection named Pasadena. And this is my talk from Scale 2 years ago, for those of you who might have made that. Add to Pasadena a pair of key values, key of year, value of 2019, key of name, value Dave. This is a valid JSON document. Now if I go back and do a find, our collection name find, you notice that we have name Dave, year 2019, like you expect. Also, the system has generated the underscore ID. This field has some information automatically generated. If you're running a cluster, it will tell you roughly the timestamp it was created and what node in the cluster is made. You can specify your own ID fields if you want. If not, the system will generate one for you. Makes it very handy. So let's say we want to modify that record. So we go out to our document collection named Pasadena and modify. We're going to find the records where the name is equal to Dave. We're going to set a new key to the value of bar. And if I go out there and do our find command again, foo_bar is now added to our document. By the way, if you do a \S once you log into our new shell, you'll notice by default that we're using SHA-256 encryption, TLS version 1.2. You can turn this off if you don't need it. By default, MySQL 8 is secure. Notice once again we're talking on port 33060. And by default, with anything JSON, the default character set is UTF-8 MB4. That's all 4 panes of the Unicode 9 character set. So you not only get support for all the standard Latin 1 stuff, plus the Chinese, Japanese, and Korean stuff, and those all important emojis. By the way, if you've been playing with Mongo and want to try out the document store, I'm going to show you an example of grabbing their restaurants collection, which they use as a training tool, and use it in MySQL shell. What you can do is fire up Mongo and find all the records. In this case, we're going to just pull everything as object ID and an ISO date ID. We do handle BSON fields, by the way. We're just going to find all the records and put it out into a file called all_recs.json. Fire up the new shell, go from JavaScript to Python. The original gentleman who wrote this, Giuseppe Maxi, our data charmer, decided this would be a cute way to import stuff. Use the JSON libraries or a regular expression library, open up the file we just wrote out, and read it line by line. Well, our engineer saw that and thought, that's cute, but it doesn't quite work as fast as we want. So they wrote a bulk importer. As you see here, you pass it the name of the file. You can give it other qualifications like name of columns you want to put it in, other conversion things you can do. And it now works in parallel as a bulk loader for JSON data, comma-separated variables, and tab-separated variables. Very, very fast. As I said before, we do have BSON support. So if you do have BSON data, just add into your import string convert BSON types to true. And you can convert date, timestamp, and all these other fields you see here. I admit, when this first came out, it knocked my socks off. Hopefully you're impressed. So now that we've imported this data, let's go out and find the records. If we type restaurant.find, in this case, there's 18,000 records, so let's limit that. You also notice how our API works to be able to add features to a command. So what we'll do is do restaurants.find limit 1, and it goes out and gives us all this information. In this case, the name of the restaurant, an ID number, where it's located, the cuisine, actually the coordinates, longitude and latitude, the address. By the way, for later reference, notice these grades here. These are from the health department. And you notice that this one has 1, 2, 3, 4 different health grades. We'll talk about that in a minute. So we just took our find, which found everything. If we want to modify that, we have the limit. There's things for sorts, halving, offsets, everything else. So let's go out and see if we can find two restaurants, but we don't want all the data. We just want to know the name and the type of cuisine. So we do restaurants.find, which fields we want to have return. Notice this is a JSON array, and we only want 2 records. So it goes out there and grabs the first 2 records, reports back to us. Now the syntax between what Mongo does for querying and what we do, I think you'll find ours is a little nicer. Theirs has a find command, but you have to pass a JSON document, say the cuisine is French, and borough, in this case not Manhattan, which is another object in there, and then the various things you want returned. Ours is a little more logical, I think. Restaurants.find, cuisine equals French, and borough not equal to Manhattan, and then the various fields you want returned. Removes are very simple. A restaurant can remove and add a qualifier. If you don't add a qualifier, goodbye data. Now, I'm going to show you a series of railroad documents that show you how the CRUD definitions were set up. Adding a record is real simple. Add 1 or more JSON documents. They have to be valid JSON documents, so the server will not take them. Modifications, you can set keys and values. You can either insert an array or append an array. You can unset values. You can get rid of arrays. You can patch things. And once again, you have sort, limit, and the ability to bind values. Remove, as you saw, is very simple. Qualifiers for sort, limit, and bind. Finding, as you can expect, would be a little more complicated because you have options for group by, halving, sorting, limits, offsets, binding variables, and for transactions you can lock shared and lock exclusive. Okay, here's an example of a transaction. For this session, we're going to start a transaction. We're going to add a record. In this case, we're adding the name, the Renee. Now, if we go off and do a test.find, we find we have 2 records. The one we just added, the Renee, and another one for Fred. If we roll back, which says we don't want to do that transaction, there's something wrong there, and do our find, the Renee has disappeared. We just have our original record of Fred. Now, as I mentioned earlier, the ID is a unique identifier. It is generated by the system. It's a var binary 32, I believe. You can specify your own. If you have it in your JSON document as an underscore ID, when the data is read in, it will try to use that as the underscore ID field. If not, the system will generate it for you. So, comparison SQL to NoSQL for MySQL. Creating a document collection. You have the command create collection versus create table with all the various columns you're going to have in there. Adding a record, as you can see, mycollection.add and then a JSON document versus inserted a test, which is the name of the schema, the table, the column where the data is going to go, and then the values. In this case, we're going to use the function JSON object to take the string test and 1, 2, 3, 4 to approximate that. Find, once again, also is a lot less verbose, so if you're a bad typer like I am, this might be a big benefit for you. Now, arrays are kind of, especially nested arrays, can get real nasty. And of course, like everything else, these words in this world, arrays start at count 0, not 1. So if you want the first record in that grade array, it's 0. Now, if you want the second to the third records, 1 to 2. Now, optionally, you can use words like first and last. So if you don't know how many are out there and you want to find the last record, you can do that. You can also compound things. So you want the first record to the penultimate record. So grades in braces there, first to last, -1. Also, one of the things you can do with MySQL that you can't do with the other JSON document stores is sophisticated SQL analysis. This is an example using a common table expression in green, think subquery. In red we have JSON table. JSON table is used to take your unstructured NoSQL data and temporarily structure it, and then we're going to run it through a windowing function for analytics. So JSON table here says, okay, go out to your JSON document, that column, find anything in the grade array, and whatever you find in there that has the key of score, we're going to cast that as an integer. Now we take all those integers, average scores, and with the common table expression, we go out and we find the top restaurant names by cuisine, and we pass that over to the windowing function for analytics, and for every cuisine we get the highest average score. So if you want to find the top 10 restaurants by cuisine, this is the type of SQL analysis you can do with the MySQL document store. By the way, the document store, you can work with the NoSQL information or the SQL information. In this example, we're going to use a table. So we connect in, authenticate in with our username and password. We select the schema we want to use, and then we say, okay, get a table. We're going to use the city table. And from that table, we're going to select the name and district, where the district is like a bindable variable. We'll bind Texas to that variable and grab the top 25 records and execute that. If you wanted to add a sort, it would be a arrow sort. If you want to do a halving, group by, offset, or anything like that, as you can see, it's very easy to extend this. Junior programmers pick this up very, very quickly. So, in conclusion, what all do you gain by going to the MySQL document store? Well, you get best of both worlds. You get the SQL language that you know and may love, transactions, ASCII compliant, data integrity. It's a platform that everyone's been running for the past 25 years, so it's a known quantity. But then you also get the schemaless ability with flexible data structure. It's easy to start with CRUD. For those of you working in environments where your boss comes to you and says, hey, start on the project right now, start building the client, and then 2 weeks from now when the focus groups get back, we'll be able to tell you what you're actually working on. This is a godsend for you. Here's an example of using non-JSON data and turning it into JSON. We're going out to the table city. We're going to put the string city with the various city names, and we're turning this non-JSON data into JSON objects. If you want to make that a JSON array, there's also a JSON array function. We also support GeoJSON for those of you in the GIS. I won't go too much into that. MySQL 8 has been a revolution in the past 2 years since it's come out. First thing is it has a true data dictionary. So if you've ever gone under varlib MySQL and seen all the little files under there, FRMs, MYIs, MYDs, that's your metadata. Now all that is stored in the database. By default, UTF-8 MB4 character set. We've added windowing function, common table expression, lateral drive joins, dual passwords, a whole bunch of other really neat features I don't have time to talk about today. We can skip locked records. So if you're going out to grab data for a query and it's locked and you don't want to read around, you can return right away, or you can skip any of the locked records and grab the other ones. You can now have an instant add column. In the past, when you added a column, it could take seconds, minutes, hours as it copied everything over to a new table. Now it just adds that column there. Added histograms, which is an alternative to indexes. Our new temporary engine's 10 to 15% faster than the old one, and we've done a whole bunch of enhancements with JSON. Speaking of JSON, if you're working with the JSON data type, I do recommend buying my book. The second edition literally came out this past week. The first edition was 108 pages. This new one's 247 pages. We've added JSON document validation, multi-value indexes, a whole bunch of other stuff that's covered in this book. Amazon has sales on my stuff all the time, so you can pick this up rather cheaply. Plenty of programming examples. Explains everything very neatly. I wrote it because I didn't think the documentation was a good learning tool. It was a reference manual, not a learning document. So this is a very cheap way to get up to speed on JSON. By the way, if you want to try the MySQL database service for free, you can sign up today, get $300 in credit. And by the way, I wish they handed all the Oracle employees who work in the MySQL group one of these cars. Sadly, mine hasn't arrived yet. If it's in the mail, it hasn't caught up to me. Also, if you are a startup and want to partner with MySQL, well, actually partner with Oracle. I am an ambassador for the Oracle for Startup group. You can enroll online at oracle.com/startup, and you get credits, discounts for 2 years, global exposure with marketing. You get promotional help, media access, mentorship, and it's a wonderful program. There's a lot of folks all over the world that are using this to their advantage, so if you're a startup, please check it out. And with that, I'd like to thank you. The slides are up at slideshare.net/DaveStokes. On Twitter, I'm at Stoker. Email address is david.stokes@oracle.com. And I thank you for joining today.